Yeah, बोल.
In MCL 321 automotive system project, now we are going to explain the working of the gearbox of Jeep, Mahindra Jeep. So let's have a look on it.
Cool.
So this gearbox has 3 shafts. This is input, this is output, and the one is auxiliary one. So first of all, let's have a look on how much number of teeth are there on the each gear. So this one has 17 number of teeth. This one has 24 number of teeth, and this one has 34, and this one has 42. After that you can have a look on the inner shaft. There is a shaft on the inner side. So this one has 26 number of teeth, and the other one gear on the back has 16 number of teeth. So there is a shaft in the lower portion of the gearbox that you can see over there. So as you can see over there, so in that shaft, this one has 40, this is 40, this has 40, this gear has 40 number of teeth, that one has 22, and that one has 32, and this one has 23, and the other one on the back has 40 number of teeth. So now let's have a look on the mechanism or how the different gears are engaged in this gearbox. So let's first of all have a look on the gear number 1. So actually, when you pull this shaft to the rightmost portion of the gear, and the other one is on the rightmost portion of the gear, then you can see that the gear number 1 is engaged. As you can see that this one is rotating on a lower speed than the input one. Okay. Now we will try to engage the second number of gear. So for that we have to push it on this side, and the lower one, so this one, when this gear is engaged with the gear beneath this, so the gear number 2 is engaged. So like you can see, this gear is engaged with the other gear on the other side. So this is gear number 2. See, now we will have a look on the gear number 3. For this we have to put it back on the rightmost side. Okay, and we have to engage this gear with that gear. कट कर देना. So you can see this is the third gear. This gear is engaged with that gear on that side. You can see this gear is engaged with that. So this one is the third gear. As you can see, the speed of this output shaft has been increased as from the earlier. Now let's have a look on the fourth gear. Now to engage the fourth gear, we have to directly connect the input shaft with the output one. So for doing that, we have to put this gear on that gear. So it is just done by just sliding it on this gear. So now you can see that both the input and the output shafts are directly connected via these two gears. So now they are rotating on the same speed, the input and the output. So this one is the fourth gear. You can see that the speed has been increased. Now let's have the look on our last gear, that is the reverse gear. Now to apply the reverse gear, we have to engage this gear with the gear there. As you can see, there is a gear there, so we have to engage these both. So now you can see that if this gear is engaged with the other gear on the back side, so this is the reverse gear then. So now this is these.
Okay guys, so the compound epicyclic gear train consists of 4 different assemblies. The assembly here consists of 3 different components. First of all, the sun gear is mounted on the central shaft. After that, it is surrounded by 3 planet gears and covering it the ring which is called as annulus. It is also called as ring gear.
And this is the.
So as we can see here, it has 4 different assemblies. First of all, the one on which I am keeping my right hand, the first assembly. Then followed by it is the second assembly. And also we can see that the first and the second assembly, they both are mounted on the same shaft. That is up to here from the start. This is the first shaft. Following it comes the third assembly, which is mounted on the later shaft. That is the second shaft. And after it comes the last assembly, and these 2 are mounted on the same shaft.
So basically, with the they has 4 degrees of freedom because of the 4 different assemblies, and we cannot have all the different assemblies working simultaneously. So we keep one of the assemblies as a constant, which is a fixed assembly. It might be the planet gear, it might be the sun gear, and from there we change for different assembly for different combinations. So
any of the assembly can be logged, and the rest of the assemblies can be managed to obtain the output rotation.
So the sun gear has 20. The sun gear and the second assembly has 25 number of teeth, while the planet gear has number of teeth as 25. And the main ring gear of both the assemblies are 75 teeth. So depending on the number of teeth, it has a different number of rotations, and the rotations will have different gear perspectives. So now we'll show you one of the very basics way how this gear plane works.
So as you can see, we can log any of the 4 given assemblies, and the rest of the 3 assemblies can be made to rotate on their own.
So let's log the second one first. So this gear is
logged this second assembly. As you can see, now I'm obtaining the rotation, and you can see the rest of the 3 assemblies rotating simultaneously. Also, we'll have a look at the engaging mechanism. As you can see, the first and the second assembly, in them they are although they are mounted on the same shaft, but they are connected with their planet gears being mounted on the same shaft. All the 3 planet gears of respective assemblies, they share the common shaft, as we can see. The same happens in the later 2 assemblies. Again, the planet gears are attached with same shaft.
So now, let's log the second one.
I have logged the second.
Now, when we rotate this, you can see this there is an output rotation here also, and only the three of these gears rotate. 3 assembly rotate. The second assembly is stationary. If you change the fixed position to the third
Let's
one,
log the second assembly. Third one. Now you can see it has been logged. The rest of the 3 can be easily rotated.
Now there's one very interesting thing you can observe here. When we rotate the third assembly, if you rotate the second assembly clockwise, the later 2 assembly will rotate anti-clockwise. This can be very easily explained with the help of the chart.
We'll have a look at the chart.
Because we always know there is a negative sign of the gear perspective, the gear change shifting mechanism. So we'll explain it through the following chart, which you can see in the current in the slide. So hi guys, in the previous 2 sections of the video we have looked through the gearbox and the compound epicyclic gear train. Now we know that nowadays for the proper rotation of the tires there is a need to have different powers in the different part of the wheel, and that power differentiation is done by differential. So this is the basic structure of a differential here. These are the gears of the differential. So you can very well see that this is one of the gear, and this is the middle portion of the differential. It has 4 different gears, and we have 2 shafts here. This is the exploded part. These are the 2 shafts of the differential, and the 2 shafts will go to 2 different wheels, and depending on the requirement of the torque and the requirement of the power, there will be a power distribution in both the wheels. So how differential basically works? The differential works on the mechanism of gear locking system, in which depending on how much power is required and how much power has to be distributed on the two shafts, it might be equal, then both the shafts will rotate with an equal speed, and the gear will lock in the same way. It might be happen that one of the wheel which required a much greater torque than the second wheel and the greater power, so the differential will provide their power. It will segregate their power through this gear mechanism. So this is the proper. These are the 4 gears, and you can see all the gears are located 90 degree in each other. It's like a pivot gears, and this is the final gear. Now we'll join the shafts and we'll show you how differential actually works. So
You can see over here.
So now see, if both the shafts are required same power, if both are rotated with the same speed, then you can see here, if both are rotated in same speed, then there is a normal rotation. But if one tire is needed a higher speed and the second tire is needed a much larger speed, then this is the mechanism.
Such mechanism happens.
This is locked.
You can see one of the shaft is locked over here, but the other shaft can be rotated.
If I rotate it with a much smaller speed than the second shaft, then it will rotate like this.
Also, the shafts can be rotated.
This will also move, but there is an unequal velocities of both the shafts. So these gears actually help in the different power distribution of a differential, and
Especially during the turning of the vehicle. Turning of the vehicle.
look there. There's one more gear there. This